How we doing, lads? Video on my home diesel heater, Chinese diesel heater. I'm building a heat exchanger for the exhaust, and this is the start of it. It's just a bit heavy steel pipe with just all bits of metal welded onto it, ground onto it. Got a bit here. Yeah. What the fuck is that? That's what started off as a bit of rusty shitty pipe, and bits like that, just bang them on, weld them on. End up with this, and my plan for this is the exhaust goes in this end, comes out that end, and the whole thing fits inside a tube. I have the tube built. I'm still working on it, I'm just tacking it all together, and here's my idea to improve the efficiency of the Chinese diesel heater. So basically how we do it, a quick idea is this guy goes in here. You see that? Yeah, so I'll put it over here. So yeah, here's my idea. The hot air from the Chinese diesel heater goes in here, the exhaust pipe goes in here, the exhaust goes through this pipe, which got all the fins on it, all these guys. Shit, fuck back in there. So it's sealed both ends of the end plate here. Still working on it. You can see how I'm tacking it all together, but that goes, so it's sealed both ends. So hot air from the diesel heater comes in here. This pipe is red hot from the exhaust. Air comes down. The hot air is coming down, being exposed to this red hot inner core, and then it comes out here into the house. This is the plan. This is the main gist. Hot air in, heater higher out. And then the exhaust, because the danger is we can't have fumes getting into the house, we'll all die. So your diesel heater, oh fuck, how will I hold this? Right, hard to do this with one hand. So the plan is, here's my diesel heater, hot air goes in there, and then the exhaust pipe, this guy, goes in there. So exhaust out, in, hot air out, in, heated higher and out. That's the general gist of what I'm going for. Now, in terms of danger, people will panic saying, by Christ, you can't have the air sitting around the exhaust pipe, and if any fumes get in, we'll all die. I know that. But what's good is, this is positive pressure in here. You're pumping air in, so it's going to be increased pressure going out. This is sealed. So any fumes that are floating or escaping around here, how are they going to get into a positive pressure environment to be blown away? So, and as to the end of the pipe, when I put that cap on, I just have him going up away from it, like, you know. So that's the start of it. To look a bit more carefully at the. Okay, come out. Oh, it's going to hit the ground. Oh, stay there. The idea with this, how I put this together, and it's a solid piece of steel, like, stay there you fucker. Yeah, it's a solid piece of steel because, you know, as I said, it's sealed here, exhausting, and I did not, because the wall thickness of the steel was so heavy, I could weld away all these parts with no fear of puncturing this hole. If you puncture this hole, there's a one pinhole in this, would all die inside from leaking gases. So I went with a heavy grade steel, so I could weld away with no fear. So I know that pipe is solid. And the way I have it laid out is the air is going to come in here. It comes in here, and these are 45-degree fins. It's essentially a big heat sink, the same as the burner itself. This is going to deflect the air. The air is going to travel up along this, hitting all these. And you know, it's just a heat sink, and it's the same as how the diesel heater itself works. Air flowing over the aluminium heat sink. This is a steel heat sink, same thing, and it's designed to sit inside that tube without touching off the sides, which it does nicely. I angled them forwards, even though they were all the correct length. I angled them forwards with the idea the airflow is coming in, and if it hits those, it's going to pull them down. I want to get the airflow to go down and stay in around this area, and then it gets to the end, and I have these fins at the same angle, 45, but this time it's to start deflecting the airflow out into the exit. You see, out into the exit port. Airflow in, fucking ourselves. So that's where I am. I've tacked it together. I've built a little frame for it over here, trying to figure out what way to align it, because it's very difficult. Like, ideally you want the air heat, you want the burner. Shit. God, I think so. We're going to seal up our heat exchanger, and we're going to go through all the welds, because there's a lot of welds and there's a lot of leaks. I don't want any leaks. Then we're going to try and finish this guy off, and the best way to do it would be okay. I made an absolute fucking mockery out of that. Jesus. I did that one the other day, I did a much better job, but there you go, that's it basically assembled now. So hot air in into the core element there with the fins on it. Jesus, they're in the right way. Through the chamber and out the other side, gaining the extra heat from the waste heat and the exhaust. I made a balls of this because I was so worried about centering it, which I have. If you look down, they don't line up. Those plates were to act as the feet, and now look, fucking ages, because I was focusing too much on getting this thing centered. But it's easy to fix that, so I have it centered. Oh! Here's where we are now. This is a rough layout of what I'm trying to put together. After I made a complete balls of welding that fucker on. At least it's centered on you. It's centered good, because it can rotate inside. Now, it's not, obviously it's not going to be the finished result of this thing rotating. I'm going to weld it all together when I'm finished and seal it all. But I'm not going. I don't want to weld it all yet. You can see what I did there, like how I made the holes, because I have hole drills, but unfortunately it was a couple of millimeters smaller than this, so I had to make the hole bigger, and there's what I did. But I ended up basically making a flange that I can weld onto when I'm ready to seal it up for good. So that's what that is. So anyhow, god damn it, fuck it. Ow, it's fuck. Burner, hot air out, hot air straight in here, into this chamber, through into the house. Exhaust pipe from the heater out, straight into this pipe. Sealed chamber, positive pressure inside. Exhaust fumes can't get into the chamber from here. As long as this pipe is not compromised, the fumes cannot escape into the airflow. If they do, we're all going to die. Exhaust out. This is the basic gist of where I'm going. And I had this tacked together, just trying to figure out what way to align it, because it's hard to figure it out. Like, you see, like I said earlier, this is your air out, and you want him going in there. So, you know, logic would say, get up, you bastard, you put it here, right, straight into it, which would be much better. But then your exhaust pipe is off over here, and he's got to go all the way over to there. I was thinking of putting it like that on top, so the exhaust comes straight down and straight into the exhaust pipe. But then you have all the ambient heat coming up off this, and I was finding it might interfere with this. So then I was thinking of putting them like this. Hot air out into the exchanger, into the house. But then your exhaust pipe is over here, and you have to get it all the way over to here. So I came up with the compromise of trying to position it like this. So heat exchanger there, 90-degree bend in, and a pretty short over to there like. Now I was wondering, should I put the heat exchanger on the air inlet? You know, I was thinking like, would that be a safer bet? But no, you're still running the same risk. And also, these Chinese diesel heaters are designed very accurately how to work. This system is designed for cold air to be going into it, or maybe room temperature air. The whole system of the control unit, it has a thermocouple on the main aluminium heat sink. It has a speed control for the motor. It has a frequency control for the fuel pump. And those three inputs go into a little chip, and on the version 2 controllers you can actually change the high speed, low speed fan, high frequency, low frequency pump. But all those variables go in, and this unit then determines, based on the temperature of the thermocouple and the heatsink, what the fan speed should be, and that's all in relation to the pump frequency. So I said, if I start blowing red hot air in here, basically, you know, the output of that goes into this, you're on a few risks. Like, first you're going to throw all those equations out the window. This thing probably won't be able to, it'll probably overheat straight away. The plastic propeller will probably melt. So I opted for fresh air in to keep this system true to its design. So I only worked with the exhaust and the air coming out. So yeah, that's where I'm at. And oh, I made some balls of that weld. Jesus, look at the state of that weld, man. Christ. I've gone through all the bits and pieces I have here in boxes, old valves and shit over there, but I can't find anything to fit it. But it would be so good to find some kind of compression fitting that would lock onto that exhaust pipe. More like it. About that. Over to there. So I'm just going to tack it all together and hope we try to get a test out of it. That's the plan now, just to tack it all together and see. I want to fire it up like and see see what'll happen essentially, you know. I got a little laser temperature to measure the heat coming out, so I can measure the temperature coming out of that, measure the exhaust temperature, measure the temperature of this pipe going in here, coming out here, and then measure the difference of air temperature going in and coming out. There should be an increase, like. So I'm going to start tacking it together and just yeah, wire it up and just give it a quick test run and see what we get. Here we are, we have this thing jerry rigged, and that's what we have. Have our burner, pipe coming out into the in, on the other side. Here's our exhaust coming out, over and in. So this is the plan, and hot air comes out here. So when you look at the travel for the hot air, it's coming out here. The minute it leaves this chamber, this air is trying to cool down. So all this has to be fully insulated. Every part of this has to be completely insulated up to the very end, which will be actually inside the house. But we're just going to test it for now, and in doing so, hopefully we'll figure out some of the problems. So yeah, let's get this thing going. I wanted to make a little clip about this because I've seen so many videos of people trying to prime their system, and they take it forever, and they have the little pump going for half an hour. You know, lads, just use your head. Suck the fuel through the pipe up to the fuel pump, connect it, switch on prime on the controller, watch the fuel getting up as far as the burner, start it. Simple. So without further ado, time for a mouthful of diesel. A little hint when you're doing this: first blow down the pipe until you hear bubbles, and you know the pipe's empty. We have bubbles. When you do that, you don't have little pockets of diesel coming up to hit you in the mouth before you get it pipe full. So when that's done, do the opposite, suck it all out. Don't know if you see that now, but I have the diesel up to there. See it? I have the pipe kinked so it can't go back. I just push this on my pump, without letting it go. Doing this with no glasses is not easy. Get on there, you son of a bitch. There we go. So now as you can see, that's my little tank. So I now have my fuel up and you can see it sitting there in the pipe. See where the fuel is? Without even switching it on yet. So I'm going to switch it on and prime it and watch the fuel go up this point into the burner. And when it gets to there, then I stop and then I start the system. So let's try that. Okay, we're now ready to prime it. This is the more recent controller, which I don't like. This, fuck it. This controller is a lot less limited. It has a lot less features, I mean, than the one before, which looked the same. But anyhow, to prime it, we have to hold down, I think it's the up and down at the same time, so let's just see. Oh, this is impossible, one hand, Jesus. There we go. So holding down these two. Oh, we got it worked. Now watch it prime it. I'm holding down up and down at the same time. Fuel's already gone through the pump. You can see it accumulating down the back, like, see? And now there's fuel going into the system now. Now there's a big air bubble there I see, like from the oh, how do you stop it? Okay, press it again. So yeah, so just one press, up and down, hold, and let go. And that's priming. Oh, it stopped itself after a few seconds. But anyhow, 12-volt battery, tank of kerosene, and this, let's turn it on. All we do is just hit fucking on. You see that? Oh my god. Yeah, we have our exhaust in there to our heat exchanger and air out there. So let's see what happens. Will it fire up? So if this idea works, I think I'll be modifying that one as well. And what's happening here? Glow plug is on, that's good. It's hard to see this in the daylight, but yeah, glow plug is on, fan is on, and we're waiting for the pump to kick in. Oh, it's tried. Flame on. I have a towel shoved in here just because of the gaps, just temporarily. Well, it's on. There's heat coming out there. I'm starting to throttle up now. Oh, I get my little laser gun. I think we'll flame out. I think the air bubble is causing me problems. How do I get rid of that air bubble? Oh no, it seems okay now. Let's set this thing to maximum. These are the new ones which are shit, like it just goes 12 volts, H5, that goes up to 6. H1, H6. Well, she's firing away now anyway. Oh, that's getting hot. That's starting to get, oh fuck, that's hot. So let's see. Yeah, we have air coming out. (22 degrees). I hope it goes a lot higher than that. Now, our exhaust 104. I don't know about these things there. They're just cheap shit from China. I don't know how accurate they are. Oh fuck, there goes my controller. That says 2033, and oh, it's getting hot there, alright, yeah. But we definitely have air coming out. Oh, it's getting hot, getting very hot. Where are we at now? Still 20, but point into it. Oh my god. 32. If I point in at the actual thing, 39, 40. It's constantly climbing. Well, that's nice. This is now 44, 49. I expect this thing to get red hot, but you see, like, it's all gaps. Like I happen, like you see, like some gaps everywhere. This is just a rough test run. There's our pipe banging away. Can't smell any fumes. Yeah. No, I love the smell of diesel fumes in the morning. Okay, where are we at now? Oh, getting hotter. See, it's climbing. Oh, hot. That can't be right. Like I said, Chinese shit, like. In there, 38. Oh, this whole thing is getting hot. Of course it's going to get hot. So, yeah, constantly climbing. You can imagine the amount of energy is being lost in this pipe, like. And that was the whole point of mounting this in relation to this, is to close this gap from the exhaust port to the import. And what I'll have is just one pipe coming straight over and have it totally insulated with high temperature fiberglass wrap, and then probably a secondary tube on that, like. But the whole point is to get the heat in here and keep it in here. Oh, that's almost too hot to touch now. Jesus, that's getting really hot. Not so hot on that end. Very hot on this end. Oh, can't touch it here. Fucking too hot here. But that's what I'd expect, like, because all the heat from the exhaust is going into that inner pipe and getting carried off with the air. Oh, that's getting hot now. So now where are we at? 50. Started off at 20 something. And if we go inside, what do we get? 64 on the inside, and like that's pointing at the, I don't know, can you see it? I can't see it in there, but we're getting 60s, whatever that's pointing at, up in that hole, so. Oh, here we go. Shut down. About 6, no, still running fine. I think maybe by disturbing the fuel pipe I caused an air bubble or something, but no, it's running okay. So, what temperature we got in the out? So that's 50, 54, 56, 62. So we'll call this about 60, and you can just imagine the amount of heat you're losing, just radiating away, like. Like I said, the whole system is going to have to be fully insulated. From here to the exit over there, all has to be encased to retain that heat. 48 out there, 60 up here. I thought it'd be a lot hotter, to be honest, but then again, it's still heating up. Pipe down here is now at, oh, we're up to the 70s down here, which is what I expected. 72. Can you see the little dot there? I don't know if you can see it in the camera. But yeah, we're at 82. Oh, so you can't touch that. So that whole inner core now is red hot. Hot air, I mean. Yeah, hot air is coming in and being reheated. All my batteries are nearly gone. I better go in charge the battery. I'm just going to let this keep heating up. So let's see what we have now. Okay, we're at 70 here. Whoa, 70. That was at 20 when I started. And think of all the energy that's been lost. The heat is radiating out. So we look inside. We're up to 80 degree temperature. 90. Fuck me. 100. See that? Whoa. Burn my fucking hand. I can't even keep my hand there. Jesus. Just gotta step back a bit. So, pointing the dot inside. 99 degrees Celsius. Oh, that is so hot now. And I can't smell any fumes off it, but then again, you won't know until you put it into your house and see will you die, I suppose. And temperature's up here now. 70. Couldn't touch that. 75. How can that be cooler on that end? 75. 80. You see that in the camera? 70, 70, 50. I think with these laser thermometers you got to take an average because it's something to do with reflectivity. The temperature coming out of this should be still the same. 60 it was, 60, 70 coming out. And the temperature here, 70, roughly the same coming out there. But inside the metal is fucking 100 degrees though. See that? Actually, can you look at the pipe? Yeah, 100 degrees. This thing. 80. Yeah, 100. Yeah, we're getting all different readings from this pipe. I don't trust these silvery things. Like that's 160 down there, which is what you'd expect, like. And that's the energy I want to get into this. And when that's insulated, we'll be getting 160 degree energy into that pipe. So this whole heat exchanger is going to be fucking red hot. And remember, we're pumping hot air into an already hot environment to increase its temperature, which isn't going to do much to cool it or take the heat away, which could perhaps defeat the whole design I had, the whole concept. So perhaps a second. I'm thinking now. Oh fuck. I mean, I'll have to insulate it. I'm going to throw a blanket over to see can we get that. It's 80 degrees there now, so. Yeah. It's been running a good few minutes now, probably 10 minutes. And we've gone with some high-tech, highly engineered insulating, which is literally the dog's blanket fucked over the whole thing. 65 on the back plate of the chamber, 70 on the back plate of the chamber. On the front plate of the chamber we have 70, 80, 70, 80, 90, so 100 degrees like. But if we can get that chamber up to 100 degrees, that's a lot of energy. Especially considering it's only got 70 degrees coming out here, like 60, 70, and we're up to 100 in here. So we're getting, we'll say 65, we'll average 65 coming out, up down there. So 65 degree heat coming out. And down here, 72, 76, 75. That's only a 10 degree increase. But in there, 80, 90. Oh, my hand. Fuck, it's too hot, like. Burn the hand off. Couldn't hold your hand there at all. The battery's nearly gone again. Fuck it. So 89. Even here. Look, Jesus. Can't hold my hand here, like. Let's try the muffler. that's quieting it. Pointing at the chair. Probably going to melt the chair, but should we look to it? This green pipe is absolute shit, right? This is polypropylene, and it reacts to the diesel or whatever fuel you use, and it will go brittle and crack. I know this is just the shit that came with it. Like, the one over there, I'm using high density polyethylene, you know, proper pipes. And as to 45 degree or vertical, I won't even go there, I don't care. But where the connection is, that's the top of your pump. That's just one of the most important things to know. And ideally you want your fuel tank above the fuel pump, so gravity feeds into the pump and then the pump pushes it up. So yeah, but this is all only temporary, just to mount it. And yeah, it's mounted. Look at the state of my welding, Jesus. So now let's, what we do now, drop it down. So it's on. I just dropped down 5, 4, 3, 2, 1. So it's really throttling down now. It's gone nice and quiet. And like our one in the house there, I mean, I run that on minimum. Like, I'll put it on full power for 5 minutes, and then it goes on to minimum and it stays there and heats the whole kitchen, like. And this one is going up there for my room. And then we'll be telling the gas company to get lost. Yeah, so now where are we at? So now we're still at 80. And the airflow significantly dropped because the fan is dropped. And what I want to know most is what temperature will it maintain? Oh, it's definitely getting colder because I can hold my hand here now. A minute ago I could not keep my hand there for more than 3 or 4 seconds. So we're down to 90. It was up at 100, 92. It is dropping, as you'd expect. $70, 80, chamber, 80. I'm starting to think now. I mean, that is fucking. Oh, jeez, that's red hot, right? But now I'm starting to think that because we're using this device, we're regaining all the energy from the exhaust. We're heating up this whole heat exchanger, and the whole system is driven by the little fan in there behind that little dot. And I don't think that fan is up to it. I'm starting to think now. Oh, airplane. Can you see it? There he is. Hello. But I'm starting to think that this fan isn't up for the... This fan will not get the energy that this is... potential energy that this unit has, but it's the amount of heat in it. So I'm thinking now, a second hole, a second pipe, a separate fan, a boost. Yeah, that's what I'm thinking now. A secondary fan, a second fan blowing a pipe in. This air is coming in, hitting those 45 degree vents. So how about a pipe coming in, pointing that way? Because we don't want to go against this. Pipe in. Big pipe, same diameter. And a separate fan with a speed control on it. Yeah, pipe. And just it just blows fresh air. Fresh air in. It's a boost, which increases airflow, which will get the extra heat regained from the exhaust, and it will transfer that into the house. Yep, we have a new plan. Okay, battery's fucking gone again. I'm only charged it up for 2-3 minutes because I'm at the where are we now? We're at, oh, it's dropping, look. It's gone down to 78. Still red hot, but you know, when you put it down to setting 1, because you're burning less fuel, in here you obviously need less RPMs, so the airflow drops, and it's airflow is what heats your home. So this thing is still 70 degrees. 60, 65, 70. 70. So we'll say on 70 degrees, and when this is properly insulated, it's going to have a lot of energy, potential energy in it. 60 out, 75 out. 15-degree increase at low power. But I'm seriously thinking, like, what if you had more airflow? And you can't adjust the airflow of the diesel heater, because the ratio, it's a calculation between the thermocouple and the heatsink, the rotation of that fan it's pre-programmed. And if you fuck with that, you'll either overheat this or you'll melt something. So I don't want to disturb this thing's design. As it stands, this thing outputs hot air and red hot exhaust gases, so we're not going to fuck with that. We're just going to take those two parameters and adjust those. Right, we've had to resort to bringing the power supply for the camera out because the battery's fucked. So what we've done now is we've disconnected the air, cup of tea and all, but you can't work without the cup of tea. But we have the air manifold, the air into the exchanger is removed, so it's blowing hot air out there. We want to see how hot this gets just based on the exhaust. Well, it's been running for probably 5-10 minutes now, and the big surprise is no heat, just lukewarm. But that's what I expect, because this pipe, which is, oh fuck, you can't touch, ow, that's red hot. All the heat is inside in that big bar with all the fins on it, and it's not touching the outside. So that shows that when the air is coming from here in here, the air is interacting, and while the air is carrying the heat from those heat fins, it's also transferring it to the walls. So that's actually good. This is cold. Holy fuck, that's actually cold now. So yeah, I got it pretty accurate. Like I wanted this steel pipe dead center of this tube with all those little fins inside, not touching the sidewall. So yeah, that worked. Like I made that correctly. Like I said, I'm going to remove the exhaust and let that vent out. So this is probably a stupid idea, but especially with one fucking hand. But it's coming. There we go. Now, okay. So just put it back on, and now our air is going in there, and yeah, we've hot air coming out over there. Yeah, here we go. It's gone up to 50. But all that is now is the heat coming out of there, through there, and out there. And there's our secret ingredient missing. So give this another few minutes. 60, 70. That's where he was, around 70. And if he stays around 60, that's a 10-degree loss in just radiating heat from here. State of those fucking wells, my god, look at the state of the wells. See how I did it? And while the thing is adjusting there, I thought I'd show you my other one. This is the first one I installed. Blowing air into the house, sucking air out of the house. Very effective. It's been working great last winter. Only got it inned up, although clearly the fucking nuts are after coming loose on it. Oh, jeez, the size of that spider. Look at that bad bastard. I fucking hate spiders. I fucking hate those things. Look at that. What is that like? Just like testing it, you know, prototype. If I'm getting the results I want to see, then I'm going to get a high temperature silicone, seal all the joints, like, because you don't want any air loss. So here I'm thinking a layer of tin foil shoved in there, a layer of high temperature putty, then more tin foil in there, like, and just crimp that to seal that. Insulation wise, I'm going to encapsulate the whole thing with fiberglass, that woolly fiberglass. That's got a melt temperature over 1000 degrees, so that should be fine, because this all has to be insulated, including this, everything from here, fully insulated. But I don't think that fan is enough to move the amount of heat being generated in here. And I think a secondary fan, a booster in effect, a boost, yeah. Pipe on here, 12 volt fan with a speed controller. So you'll have your controller in your house, plus a little knob for a booster. That's my thinking now at this stage. Battery's nearly gone again, gotta plug it back in. Where are we at now? I can't think. 87 and climbing, 90. Oh, sorry. 91. Let's see. Oh, too hot. Okay, we have it expertly insulated here, very high engineering standards. You can see very exacting standards of engineering. But yeah. Jesus, you can't keep your hand there for only a few seconds. So, right, the wall, 73. Right, the inner. Jesus, too hot. Like, I can't keep my hand there. 90. Oh. 100 degrees. We're getting 100 degrees temperature in that center core. 100 degrees Celsius, boiling water temperature. Exhaust temperature. I don't trust this reading with this shiny surface. 50. Plate. Yeah, 87. That's more like it, yeah. Hang on, read the inside. 36, 42. That is a lot hotter. Like, your 72 flashed up there. That'll be more like it. Oh, I'm getting the readings on the darker. Look, 80 degrees. So you have, took off the blanket and 70, 57, like that was 80 when I took off the blanket. So already dropping down like crazy. That shows you the amount of heat loss from lack of insulation. But the more I think about this now and looking at it, I'm pretty sure that this arrangement is generating huge energy in here in terms of heat, but this fan is inadequate to pump enough air through it to extract that heat. Would that be a correct assumption? Because you're looking at air at a temperature of 60, 70 degrees, going into a chamber 100 degrees, bringing it up to a grand total of, we'll say 80, so that's only a 10 degree increase. I don't know about thermodynamics, but trying to heat air, like warm air, passing over a hotter substance is not an efficient way to reclaim energy. But we put a second pipe with a separate fan, a 12 volt fan, a speed control. The pumping will just increase the airflow, especially with cold air, because cold air will heat up twice as fast. So that's my next plan. Drill a hole, secondary pipe, a booster in effect, a booster fan to double the airflow and extract as much heat from that steel into the air coming into the house. So that's where we are. Oh, Jesus, my knees. And I could mount him in there. I've already welded it all in place. Oh Jesus, here we go again. Or maybe mount them that way. And they have nice little 45 degree angles. I'm wondering, could I introduce extra air from out here? You see, what I don't want to do is create back pressure on the air coming out. I think the only way to do that would be to mount a separate pipe coming in here like this, and then somehow bend it inside so it shoots the air down. So I do not want to create a back pressure up through this, because that will fuck with this. So that's it, trying to shut it down. God, that's one funky noise. Yeah. Yeah. Secondary air pipe. Separate 12 volt, it's 12 volt system, so I already have the power there. 12 volt van only run a few amps. And I'm convinced that by pushing more air through this, I will get more efficient output. I get a bigger volume of warm air coming. It may not be as warm. I mean, nobody really needs 90 degrees Celsius heat being shot into their house. I'd much rather have twice the volume of air at 50 degrees. So if I work out the airflow from that pump, it might actually be written somewhere on the specs. If I could double the airflow with a secondary air pump, and introduce it into the pipe, making sure there's no back pressure, then that would increase the whole system performance, and it would extract all the potential energy in the heat of that steel. Yeah. Strange that these ones shut down like. First it slows down to almost nothing, and then, you know, first it kills the pump, kills the flame, and it slows down, and it waits a minute, and then it turns the fan back on again to cool itself down. It doesn't make any sense at all. I'd far prefer the one I had over there, like. But anyhow, yeah. Yeah. So conclusions. It's demonstrated that there is an increase in heat from going in to coming out. We've demonstrated that that inner pipe gets fucking red hot up to 100 degrees. So that's transferring the energy from the exhaust into a place where we can use it. But with the temperature of the air coming out of the heater being at 60-70 degrees, passing that over heat baffles that are 100 degrees, I reckon the energy transfer from the hot steel to the air is very slow compared to cold air, compared to cold air going into it. So I reckon, yeah, secondary fan, secondary air introduced into the heat exchanger will definitely remove more of the heat. Because I mean, on the exhaust, the amount of heat coming out of the exhaust is still like, I want the air coming out of the end of the exhaust to be cold. And if you get there, then you know that you're regaining all that energy. So that's what we're going to do, folks. We're going to shut it down and rip it all apart. And I'm going to figure out a way to get more airflow into it. And the more I think about it, like, to do it, like, you can't put a little pipe, like, you can't put a pipe, you can't use a pipe that diameter. It has to be a big fucking wide pipe going into the side, the far side, because it's volume of air, like. And a pretty nifty fan off a computer or something on a 12 volt speed controller. Couldn't do that a minute ago. So that's it, yeah. Any ideas, lads, let us know. And again, don't subscribe. I couldn't be arsed with any of that shit. Like, subscribes, notification, fuck off. Yeah. Anyone got any ideas on heat transfer from warm air passing over warm steel? Like, I mean, I assume colder air, it's all about thermodynamics, but I imagine colder air would be far more efficient at extracting the energy out of hot steel. Yeah. Go on, good luck.